differentiation of a certain function. And now, when we are dealing in derivatives, no, it is connected to the change of rate. Do you want to see? If ever you want to see, please get the HDMI. Sorry people ha, some of the 10A and 10B are here and 10C. The HDMI, it's upstairs. It's in the table. You get so that you could watch here. Yeah, they are here. Sige po. Sige, go. You get the HDMI. You just follow po. Sige po. HDMI. Sige po. HDMI, the cord. You know that one, you get that one so that you would have a
HDMI, sir?
Yeah. Yeah. You already. Be quiet. He is taking the quiz. Okay. So when we are dealing in okay, so when we are dealing in derivatives, no, we tend to tell that it is the change of rate. Do you remember still what is? Hey, get already. HTML. When do you remember when we have a slope? What is the formula of the slope? Sige po, who remembers the formula of a slope? Yes po, what's this one? Yes, Brendan.
Sir, can you hear me po?
Yes po, loud and clear.
If I'm correct po, that would be rise overrun.
Rise
Overrun.
overrun. Or what is our rise?
Y. Y-intercept po over the x-intercept.
Y-intercept over x-intercept. Correct? Or delta y over delta x. Correct? So,
Ay, sorry sir.
Yeah, sige po. So when we are dealing in slope, in derivatives, it is telling that we are connecting the slope itself as a tangent into the steepness of a line. So when we when we talk about slope, it's about the steepness of a line, correct? It is about the steepness of a line. But when we say differentiation or derivatives, it talks about the change of rate. How is the steepness of a line being changed? Or how is the steepness of a curved line being shown? How is it? Because for example, in a mountain, what is the highest mountain in our world? Sige nga po, who can tell me? 10A, 10B, 10C. Yes po. From Hermione, Mount Everest, correct. So let's say this is Mount Everest. Okay, this is Mount Everest. That is Mount Everest. No? This is Mount Everest. Yan. So when we have Mount Everest, let's say that is the highest. Okay, that is the highest mountain in the world. Can we say that that highest mountain is the hardest mountain to climb? Is that? Oh, sige po. I will ask you to do ha. I know that you are in your homes. Would you mind to search what is the second highest mountain in the world? Go. Get an extension as well. You cannot. Come on. Oh, what is the second highest? K2, correct. K2 ha? Yes po, correct. 10A, 10B, 10C. Okay. So, the K2, let's say this is the K2. This is the K2. Okay? This is the K2. Now, would you mind to tell me if you visualize what is the two from these two mountains, which is harder to climb? Mount Everest or K2? What do you think? If you will be the climber itself. Okay, so Brendan K2. K2. Why did you say so? Okay, let's have Kate. You cannot have that one. You get the
Can you
extension.
hear
Oh,
me,
let's
sir?
have Kate. Yes po, I can hear you.
The K2 Mountains steepness makes it harder to climb up.
Correct. Right? So, when we are dealing in slopes, we talk about steepness eh. But when we are dealing about differentiations, we could refer this, yes, but you're done already. Where's your solution? Wait a minute. Oh, you show your solution here. Yeah, you show your solution. So when we are dealing, you fold it, I need it crosswise. Even at the back. Please wait until hand. Yes, when we say crosswise, this is the crosswise. Okay. So when we are dealing in differentiation, we could have an example. For example, our Earth. Because when we say change of rate, the steepness is being moved or being changed at that moment. Because when we are dealing in mountains, it has constant steepness, right? For example, the steepness of Mount Everest has the constant value of this value. Compared to uh, compared to K2, right? K2 has the constant steepness as well that we know that it is much steeper compared to Mount Everest. But the thing is, when we are dealing in derivatives, the steepness is changing. Okay po? The rate of steepness is changing. Let me give you an example. For example, in our world, I'm going to ask you, our world, let's just say, this is our planet, correct? Would you mind to tell me if the planet that we are living on is round or flat? There are. What do you think so? Is it round or flat? What do you think? Hmm? I'm not entering into some kind of theory because there will be say, oh, you're kind of these people, you're believer of flat round. No, don't believe that kind of situation. I'm just asking. We could say that um we could say that the earth is round, right? So if we are going to deal in a round earth, you will notice let's just say that this is our world. Okay? Sige po. What's that one? Yes po. No? It's in estimation, it's about totally round. Okay. So let's just say this is the Earth, right? So let's just say that you are in here. Okay, you are in there. No. So why do you think? Because we could see that all of us are living in a plane surface. Correct. We are living in a plane surface. Correct. Why do you think? Like, if it is not, for example, you're telling, it is a flat surface, Sir Jai. We are living in a flat surface. If you are living in a flat surface, um, what do you call this one? If we are living in a flat surface, you can see that this point that we have a while ago, no, is observed in a tangent line. Would you mind to define what is a tangent line? This tangent line is being discussed even in grade 5. Do you know what is a tangent line? Would you mind to tell me? What do you think so? We cannot see beyond the distance. That is why, yes po, that is what I'm telling, no? So, if you are in this curve, you cannot really tell that it is round during that time. Okay? But, once we get closer, for example, once we get closer to the surface, it is somehow getting flatter and flatter and flatter. And let me tell you, what is the formula of circle? What's the formula of a circle? If we are getting the circumference. Huh? Pi r squared, that is the area. People who are sitting here. So the formula of circumference is 2 pi r. Okay? So knowing that there is a pi, what is a pi? Oh, sige, we're going down already in the elementary stage, ha? What is a pi? Do you think? It has the value of 3.14, but what is a pi? Oh, what seems like Hermione, yes po. What's a pi? Hmm? Yes, what's a pi? Do you think? Dia diameter, why is it circling? Oh, let's just say for Vinaya, kinakain po sir pi. Brendan, ratio of what?
Sir, can you hear me po?
Yes po, loud and clear.
I'm so if there's a pi that is involved, there's a circle that is also involved. So a circle is a 2D 2D shape with no sides. They cannot be a triangle, they cannot be a rectangle or whatsoever. So having a circle means having a pi. So a ratio for a it's a particular ratio for a circle.
Uh-huh. Ratio of a particular circle. And what is that particular value? I am telling you, why are we, if you're going to ask me, like, why are we discussing this one? Because you cannot solve and solve and solve if, in the first place, you cannot understand what is differentiation means. Okay po? That's the first thing that we need to discuss right now. So, what do you think? What do you think? What do you think? These people, eh? Here, in the second part. This one.
No, not there.
No, that one, this one should be in my laptop.
Ah,
Baliktad ka, pre.
it's the same.
Oh yeah, but there's a problem. Okay, again. Sir, you asked the grade 10 there. Sige po, I'll be asking you daw. As by the stencil. Okay, you people who are in here, would you mind to tell me what is a pi? Si Atina daw po. Atina. Yes, we know that the value of pi is 3.14, but what is a pi? What do you think? Huh? The area, no. We're telling, for example, we have circumference. Let's deal with the circumference. We have a pi there, correct? Whether it's area or circumference, there is a formula like 2 pi r or pi r squared. What is a pi there? Again, from the definition of circle, we cannot just simply have pi itself, no? Because circle consists of points. Correct, people? Circle consists of points that makes up it as a circle. Like starting from the square, what is the next polygon after square? Pentagon. Correct. Next, what is the next one? After, again? See, they are answering. Come on, people. Answer also. Hexagon. After hexagon, heptagon. After heptagon, what? Octagon. Next. Nonagon. Next. Decagon. Next. Didecagon. And so on. 25th gon, 26th gon, up until 100. Up until, if you're going to look for the infinite, no, sides, it will turn up to pi. That's why, no? And we are telling that from the 3.14, it is an example of, or it is the ratio. Please take note, please take note. It is the ratio of, if we say ratio, that is comparison of two quantities ha. So there are two quantities that you need to compare. First is the perimeter of the circle or the circumference of the circle towards to the radius. Again ha, the circumference of the circle and what? The radius. Okay? Fix this one, Justin. Okay. Please wait. We're discussing. Can you maybe that one? Yeah. So you can see them as well. Here. This way people have.
How's that?
Okay. They can see you here. Okay. Ay! Okay. They can see you. Yes po, yes po. Please wait. So that they can see you. People, you're too noisy daw, people. Okay. This way, people. One of the problems. You're done already, Paolo? Almost. Sige po. Please wait, people. So when we are telling pi, once again, no, it is the ratio of the circumference of the circle towards to the ratio. So if you will notice, once we have the circle itself, if you will remember the parts of a circle, we have what we call the center, the radius, the diameter. Okay, they can see already. The center, the radius, the diameter, the chord, no, the chord, the secant, and the none, and the tangent. So when we have this, so when we have circle, sorry. So when we have circle, this is our center. We have the radius, we have the diameter. This is a chord. When we say secant, secant is a line that passes through a circle, whether it deals with the center or not. Okay, as long as it touches 2 points of the circle itself. But when we tell tangent, it meets the point of tangency, or it is a line that meets 1 point of a circle. So when we are in the tip, no, so you are in your location at your house right now, no, so we could see in our environment that we are in a flat surface, because once we get closer, it becomes flatter. Okay, so in terms of uh in terms of people, yeah, it's hard pala, no, if it's like this. Okay, so when we are telling differentiation from the change of rate, from having the change of rate from your slope, which is this one, if this is your slope, the point of steepness through your slope, if we are talking about slope only, that is constant. Correct? That is constant. So when we are telling about the steepness, once again, the slope of the K2, the slope or the steepness of that one is still constant. But when we are talking about the steepness of a curve line, it changes. For example, let's just say volcano. Oh, the shape of the volcano is like that. Oh, when you are in grade 1, the drawing of the volcano of yours is like that. Correct? There's a curve. Correct? So, seems like from your thing, let's have this one. So from your thing, when you are starting in here, the steepness of yours is not directly towards to the tip of the volcano, correct? Right? So you are starting from the bottom, going here, and it changes when your position is at this position already. It changes the slope. So when you are here already, the steepness or the slope of yours is in here already. So if you will notice, the tangency of the curved surface is moving, or the rate of that um, curve line or the graph of that you have is changing. So that is where differentiation will go in our topic. Okay po? So that is differentiation of a function. When we say function, what's a function? Once again, when we say yan. When we say function, it is what? Let me call on from 10A. 10A, let's call on Nathaniel. Nathaniel, are you here? Nathaniel?
Yes po, sir. Sir,
Please
can you
wait.
hear me po?
Yes po. Please wait, please wait. Don't answer yet. I'll just... Would you mind to... Sige po. Would you mind to talk, Nathaniel?
Yes. Hello
Nathaniel?
po, sir.
Ay, please
Okay
wait,
na po,
please wait.
sir.
Would you mind to find the volume
Oh.
here? Hey, Justin. Volume here. So that they can hear as well. The volume. Come on, these people. Volume. Would you mind to check the volume? On this part. The volume. There's a volume there. Pictures nga.
Sa likod.
Sorry people these people kasi. Sige.
Careful naman!
Go people.
Wala mangyayari.
Pinipindot ko na sir.
Baka sa kabila.
Ayun. Would you mind to speak once again?
Hello po, sir.
No, I can still hear you. Please wait. I'll make way. You can see them. Sige po. I'll be the one to adjust once again. Would you mind to speak for Vinea? Yes po. Go! None still? Please wait. Please wait. So that we could fix. I thought I could see. Pwede na po. So somehow I could adjust and see. Ay. These people. Please wait, people. So once again when we are talking about the rate of change, it's all about the changes within the rate of the tangency of a line or the steepness of a line. Ha? Let's just try this one if it's possible. Yun. Okay. Once again, Fervine, would you mind to speak? Yes po. There's still none. No, they are not muted. No. I know you are doing that one, but I'm not doing that one. No, not that. Because we could hear the audio of my Spotify. Oh, here's the see. So it's not with me. So you better join if you want to. Or you just join. The code of the other one is OTZZECV. Then the other one. There, oh. You just copy the code and you just enter so that I could hear them. Sorry people ha. This 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 baby 10 A's and 10 B's. Sige po. Come on people, don't play already. Okay. Oh, who will be entering the other one? There already. Okay, so once again, Nathaniel. Come on people.
Yes.
Nathaniel, once again, what is the answer? I
It's
can
ano
still
po,
hear you.
right?
I
The
can
question
still
po
hear you.
is what is a function po, right? Sir?
This way, people. Okay, once again, let me try. Yes, Nathaniel.
Sir, the question po is what is a function po, right?
Wait, this sorry. Wait, Sige po. Once again, would you mind to try, Nathaniel?
Sir, can you hear me po?
Yes, I can hear you
Sir, the
already.
question po is what is a function po, right?
Yes po. What's the function?
I think po, function po is like a relationship or a connection po where there is an input po and an output.
Correct. No, so when we are talking about the function, it has the relationship between the input and output. Correct? Because we are trying to get and analyze what is the functions that you have within your equations. Okay, so let's deal with the numbers already. Now you define already what is the differentiation or derivatives in a function. Let's deal with some numbers already. Okay, so if you have your book right now, do you have your book right now? Do you have your book right now? Maybe you could have seen there. No, you could see there. People, sige po. You could use my book. Come on, people. Sige po. So with that book, okay, maybe you could go to the page. What page is the first lesson in derivatives? Maybe it's page 70 something. 70 something. 57. Yeah, correct. All right. So we have a formula there which is written as let's change this one into okay. All right. So we have Mm, people kasi. Come on. Okay. So we have the formula of f of x. This is a function, f of x, wherein you're trying to get the derivatives of a function. When we say derivatives, if you will remember, Brendan, uh, if you will remember only, I did tell that, I correct my mistake during that time that I multiplied something. If I don't know if you will still remember that one, no? But I did told you that it is a little bit deeper in math, no? And that is what we call as prime. When we talk about prime or f prime x, that is the derivatives already. Okay, that's why I'm not telling, because you will not yet understand that one unless we talk about the function already. So when we have this function, the prime of a function or f prime of x, no? So we are trying to get the derivatives of a certain function with the help of x plus h. Okay? So there are tips and tricks in getting the derivatives of a certain function. Let's just say, for example, no? Let's have an example in here. Okay, you can see my presentation still, na? Sige po. Let's have an example in here. Sige po. Here. Okay, so let's have an example, for example number 1. Okay, so when we are dealing in function already, we need to find the limitation of a certain function with the help of x plus h. But before we turn the whole function into a limitation, no, maybe you could write first the limitation of x as it approaches to 0 or h. Let's have this one. Okay. So this is h, wherein it shows that f x plus h minus f of x all over h. So what you are trying to do in there is to find first the values of f of x plus h and f of x itself, or the function itself, plus the whole limitation. So in order for you to get the f prime of x, no, you need to find first the three things. What is that one? Once again, you need first the f of x. What is your f of x? You already have 16x. So let's have 16x squared. So you are trying to find the f prime of x, correct? But you don't know yet because it is the whole um, derivative of the whole function. But you need to get first the f of x plus h. So when we tell f of x plus h, yeah, we're dealing in f of x plus h, it means that all x that you have in your function, you will convert that one into x plus h. Okay po? So what is that one? So what is our f of x? Our f of x, remember the composition of function? Composition of function. When you have f of g, remember ha, it only denotes that the input of your f if g is g, correct? So instead of putting x inside f of x, you put g, correct? G of x, right? Who is this one? Ito, Campo. Okay. So going back, so when you have already f of x plus h, you need to substitute all your x to x plus h. So what we could have is x plus h, correct? So it will turn out, instead of using that one, it will turn out as, what is your f? Your f is 16. 16. 16 x plus h. Oh, but don't forget that you have squared. So you need to put the square. Gets? Gets already? Okay. Next, The third step is to check. What's the second step? What's the second step in the book? Kindly check. 10A, 10B, 10C. If you have your book, what's the second step? Hmm? F of X. Come on, let me see. Let me have the book nga. You're not using the purpose of the book so that you have a manual, people. Okay. The second step is to find the difference between the two. Oh, sige po. Come on. Oh, now first find your f of x and f of x plus h. Now, when you have f of x and f of x plus h, you need to find the difference of that one. F of x plus h minus f of x. Okay po? So how is that one? So we are going to convert or substitute all the values of that one, and that would be of 16 of x plus h squared minus 16x squared. Correct? Okay, so once we have that one already, how do we deal in this scenario? What do you think? What do we need to do? Hmm? Oh, people of the Philippines, how about you? What do you think we need to do? Hmm? Hmm? Can it be that I'll just show this solution? Oh, ay, come on. That's why I am showing this process so that you'll understand also. Because if I'll just present all the process, I could easily give the PPT, right? So in that case, remember you still have this x plus h squared. So what you need to do, not to substitute because we already substitute it, what you need to do is to FOIL it out. FOIL that one because that is binomial. That is x plus h multiplied by x plus h as well. Correct? Oh, minus what? Hmm? Oh, what? Hmm? Oh, what's the FOIL of that one? That is x squared plus what? xh outer and inner. Oh, xh plus xh plus h squared. Correct? Minus 16x squared. So if you will notice, this is 16. Correct? Mm. Sir, how do we deal in this format? So if you will notice, this is the time that I will be showing you the process. This is the first step. I will be showing you step by step. The first step, if you will notice, we have already this part. Correct? And this part as well. So the next step we need to do in this part is to FOIL it out. To FOIL it out. Once we FOIL it out, if you will notice this XH and XH, that is 2XH ha. If you will notice, we cannot just simply put 16 there ha, because one of the mistakes of grade 9 pupils when I was in grade 9, they're just connecting the dots. But it is not. Please remember, if you have 16, you could just distribute the 16 to your x and h. So basically, you have 16 in all variables or in all uh, terms that you have in your binomials. So in order for us to make it much easier, find first the FOIL of your binomial. Once you find it out already, that's the time that you could input the 16. So in other words, that's the time that you could distribute the 16. Right? So after that one, after you distribute, or either way, you could simply multiply them because it seems like multiplying, right? When you are distributing them. Once you have it all already, we could cancel this out already. Correct? Oh, there is someone who is calling. Later that call. Okay. So we could cancel it out. So what are the values that we still have in our equation? We still have 32hx or 32xh. It's up to you. But again, in terms of variables, letters who comes first should be on the first in line. Followed by plus 16h squared. H squared is the last term that we have in your polynomial. Correct? Okay. So in that case, we have now 32x plus 16h. Sir Jai, why did it happen that the h below of your fraction was gone already? What is the factor of these terms? What's the factor of these terms? Can we factor it out as h 32x plus 16h? Can we? Because when we distribute the h, it will become this one, correct? So we could have this form already. In that case, we could cancel the h. Okay, so we now have 32x plus 16h. Now, that is the third step that we have for your differentiation. Then the last step is to find the limits of that one. So go back to the limits, ha. When we say limits, ha, we have h approaches to 0, and we have to find the limit of 32x plus 16h. I'm not yet showing, ha, but remember, how do we find a limit? If your limit has a value, what's the value of your h? You are referring the limit of your function as h approaches to 0. It means that all the variables in your term will be substituted with 0. Correct? So this 16h will substituted with 0. So obviously this 16 will turn out as 0. It will be 32x plus 0. Okay? Gets? Or in other words, we could have the final answer as 32x, or we could say the f prime of x is 32. So we could also say that the derivatives of your function 16x squared is 32x. Okay po? So the process first, once again, let's go back. The first process is to find the f of x plus h, then f of x plus h, then you subtract the f of x to your f of x of h. You will notice this one, you subtract that one to the f of x of h. In order for you to divide it by h, and you get the limitation. So you only have like 4 steps only. Are we clear? So with that said, we're going to continue this session, this discussion. I do hope that that 4 process, no, from that 4 process, you already incorporate like what is the first step you need to do in getting the differential from your function. Again, what is the first step? What is the first step? Let me ask Sarah, Marie, class number 23, 10A. Anabo?
Hi, sir.
Yes po, hi po.
I'm going
Yes.
to get my book.
Ay, come on, you're just going to get your book? Yes, what's that one? Yes.
Other na lang, sir.
Hmm?
Other people. Hehe.
Please wait, ha. Okay.